Okay, hey guys, let's go ahead and get into the next topic, which is weak bases. Now, principally, this is not any different than our weak acids. It's just a little bit different. So let me show you this so you can see that they're similar, and we should be okay. All right. Sorry, didn't mean to touch that. Oops. Apologize. When we talk about bases, anything that's not a strong base is a weak base. Same deal we've talked about before. We have a base, it reacts with H2O, it becomes a BH plus and an OH minus. Okay. We have our KB, that's BH plus times OH minus over B. The value of pH is related to the value of K. Okay. So if it's a good base, we get more OH minus, that raises our pH. If it's a bad base, then that's not so true. Large Ks are stronger bases. In order for that to happen, we need to have a good situation where that base is more stable, having the H plus on it. So if our base is in a situation where it's highly reactive, like NH3, it can be more favorable to have that H plus. Now, it's not perfect, but it can be more favorable to have that on it. Okay. We need to make sure that there is a bigger affinity for the H to the B than there is to the water. So, greater affinity B to H plus than H plus to OH minus. Okay, so that needs to be another thing that we need to have. That's the same kind of principles that we talked about before. All right, so that's what we're looking at in terms of weak bases. Now, when we have weak bases, apparently I have this in there twice. Well, isn't that fun? Sorry, it's going to bug the heck out of me if I don't fix that, so I'm going to fix that. I apologize. That shouldn't have happened. Go back to the normal view. So, weak bond between the M and the OH so that can come apart. That's one way. We need to have a more stable metal ion if we're losing the OH minus. And the MOH bond must be polar. Okay, so that metal wants to lose those electrons in that case. Now, if we're picking up a proton from other things, we have to have a greater affinity for that proton to the base, so like to NH3, than we do for OH minus. Okay, and that's what I was saying before. All right. We can also set up Rice tables for base equilibriums. So if I have the reaction of NaOH going to Na plus OH minus, I get a Kb is equal to NH4 plus times OH minus over NH3. Kb for that is 1.8 times 10 to the minus fifth. That gives us a Kb equal to X times X over NH3. Now, if we have our initial concentration of NH3 is 5.0 times 0.5, just like we did for the HF, and no NH4 plus and no OH minus, we lose an NH3 for every NH4 plus and OH minus we gain. So while that NH3 should be 0.50 minus X, we ignore the X, and that's how we get that X times X over NH3. We substitute the 0.5 for the NH3, and then we get the equation here. So Kb is equal to X times X over 0.5 times 1 equal to 1.8 times 10 to the minus fifth. X squared is equal to 1.8 times 10 to the minus fifth times 0.5. And that gives us an X value of 0.0030. Now, is it sometimes necessary to use the quadratic for this? Absolutely. But just like we talked about before, even though I'm showing you this, you are not going to be required to use it. This is just how we do that. And then we can test that assumption to make sure that the X value is smaller than 5% of the initial concentration that we had. Okay, so this is no different than what we talked about for the acids. We're just looking at it for a different type of equation. Okay, so that's our base equilibrium. If we're going to do that, let's do some examples with weak bases so that we can see how the math looks when we do this. So the first one we want to look at is methylamine. And this is going to be price for weak base. And I need to show you that. So methylamine, CH2NH2, has a Kb of 4.4 times 10 to the minus 4th. What is the pOH of a solution of methylamine that is 4.37 times 10 to the minus 2? Okay, so we're talking about the reaction of methylamine, CH2NH2. Okay, and that's going to react with H2O. That's going to give me a CH2NH3 plus. So I add that hydrogen to it and add a plus charge because adding the proton adds the plus charge. And then we're going to be left with an OH minus from the H2O. Now, when I do the setup for this, I have my R here for the reaction, and I have my I, C, and E just like I always do. This H2O is not in contribution to this because it's a liquid. So even though it's present in my balanced equation, it's not part of what we're going to be looking at. My initial concentration for the methylamine is 4.4 times 10 to the minus 4th. I assume I have none of the methylamine cation and the OH minus. We're going to subtract 1 from the CH2NH2 for every CH2NH3 plus we make, and for every OH that we make. Okay. And that leaves us with 4.4 times 10 to the minus 4th minus x, but we ignore the x and x there. Kb is equal to, oh, that's not the right value. I apologize. That's my Kb, not my initial concentration. Kb, my initial value is 4.37 times 10 to the minus 2. So my Kb is 4.4 times 10 to the minus 4th. That's equal to x times x over concentration of CH2NH2. And of course, that x times x came from the CH2NH3 plus and the OH minus. Okay, so that's where those two x values came from, so just so we're clear. Now, when we do all of this happy stuff that's in here, we have our concentration of CH2NH2. So 4.4 times 10 to the minus 4th is equal to x squared over 4.37 times 10 to the minus 2. So my x squared is equal to 4.4 times 10 to the minus 4th times 4.37 times 10 to the minus 2. That gives me an x squared equal to 1.9 times 10 to the minus 5th. And of course, if I take the square root of that, that gives me x equal to 4.38 times 10 to the negative 3rd. And of course, that should actually be 4.4 times 10 to the 3rd. Okay. What is that x again? That's my OH minus concentration. So if this thing is looking for the pOH, I can take the negative log of the 4.4 times 10 to the minus 3rd, and that's my POH, negative log second answer, and that gives me 2.36. Okay, again, 2 sig figs, so 36 for 2 decimal places, because it asked for POH. Awesome. So now I have POH. Cool. My next thing says caffeine, C8H10N4O2, is a weak base with a Kb of 5.3 times 10 to the minus 14th. What is the POH of a solution of caffeine that's 6.52 times 10 to the minus 2 molar? Okay, so we're going to set this up the same way that we did before. C8H10N4O2 reacts with an H2O to give me C8H11N4O2 plus, so I just took and put that proton on there, plus NOH minus. Now, I don't actually know at this point where that thing lives because I don't know what the structure of this thing is, and that's okay. We don't need to know. We just need to know that we added it. This is an R, this is an I, this is a C, this is an E. My Kb for this is 5.3 times 10 to the minus 14th. My initial concentration is 6.52 times 10 to the minus 2. Okay, I assume I have none of this and none of this. That is not part of it. We'll subtract an X from my caffeine every time we do one of these reactions. We'll get a plus X for the protonated base and a plus X for the OH minus. Equilibrium is going to be 6.52 times 10 to the minus 2 minus X. We ignore the X. This is going to be an X. This is going to be an X. And so my Kb is equal to that 5.3 times 10 to the minus 14th. That's equal to X times X over 6.52 times 10 to the minus 2. So I get my X squared, and that's equal to the product of the 5.34 times 10 to the negative 14th times 6.52 10 to the negative 2. So X squared is 3.48 times 10 to the negative 15th. Take the square root of that to get X. And then X is going to be 5.90. 2 sig figs. Well, 3 sig figs. It should be 901 times 10 to the minus 8th. Sorry, it should be 90 times 10 to the minus 8. If I want my POH, that's equal to the negative log of that value that I just calculated. And that's equal to 7.2. Okay, it's 7.23. And that's the value that they asked me for. Awesome. So again, setup here is not distinctly different. What you need to remember is that in one case you're calculating H plus, in the other case you're calculating OH minus. Be careful, because we don't always ask for H plus or pH when we're talking about acids. We sometimes ask for OH minus and POH. Same is true when we talk about bases. We don't always ask for POH or OH minus. Sometimes we ask for H plus and pH. Okay, so make sure that you read the question. That falls into the RTFQ category, and being nice about it, read the full question. Okay, so let's make sure we actually answer the question that's been asked. Questions about that? I hope not, but again, that's the same kind of thing that we've been talking about. There will be more practice for this as we continue. And so let's make sure that we get that done. I'm going to stop here and give us a break before we go into the next part of this topic. So I'll see you soon.